Comparing fractions. We'll start with this one strip representing one whole, and then we can use that as a reference for our fractions that we'll be creating. So here I'm going to make halves.
Half machine.
How would I do that? Well, I take this whole and I put it through the half machine. Probably a lot of you already anticipated what I'm going to do here, lining up end to end, because they need to be pretty close to perfectly equal. If they're not equal, they're not halves or fourths or fifths. They need to be equal size pieces. So if I open this up, how many pieces will I have? 2. And how many pieces will make a whole? Also 2. Will the pieces be equal? They better be. And now we have 2 pieces that make a whole, otherwise known as halves. Okay, I can crease that and tear it so that I have 2 equal halves. And on the back, I'll write 1 out of 2, because there's 2 pieces that make a whole, and this is one of them. And also 1 divided by 2. Because if I take this 1 and I divide it into 2 pieces, now I will have half. Or we're also saying how many 2's go into 1. It's a flip way of looking at that. If we had 2 wholes, how many of these would make 1? Well, 1/2 of that group.
That was half machine.
Next is thirds. Thirds are the trickiest one to fold because we have to do this little loop-de-loop thing.
Third machine.
Like to get a letter into an envelope. So the way you do this, and this might take a few tries if you're doing it on your own, is we need to try to line it up so that we create 3 pieces. We have to kind of do some scooching, and when we bring this closer, we scooch, scooch, scooch. So we're trying to have all of these 3 chunks be as close to equal as we can get. And then we crease it. How many pieces will we have now? 3. How many pieces will make a whole? 3. And are they equal? Oh, that is not equal, so that is not thirds that I created. So I need to try again. Maybe I'll try a different color because I like to mix it up. Scooch, scooch up with my 1 whole. And the tricky part is to get them all equal. Ooh, this one looks better. So I'll make some nice creases. When I open it up, I should have 3 equal pieces. And as you can see, when I overlap it, I will call that good. So now, of course, I have thirds. That's 1/3, that's 1/3, that's 1/3. And on the back, I will say 1 out of 3 pieces, 1 divided into 3 pieces. And I'll just say 1/3 on this last one. I don't have the other comparisons we'll have soon. So again, I can crease it with my thumbnail so it's easier to tear, creating my thirds manipulative.
The next is
fourths. So we're going to want 4 equal pieces. You may already know how to make fourths, and it's using one of the machines we already did. So this was half machine, just folded in half, right? Hot dog or hamburger style. This is third machine, so we made a little loop-de-loo and lined it up. And this one, yell it out at home. What machine am I going to use to make fourths?
Fourth machine.
If you said half machine, you are so correct. So we go half, and then we do another half machine. So fourths are actually easier than thirds because we don't have to do that awkward lining up the loop-de-loo thing.
So fourth machine is 2 half machines. Go half machine, half machine.
I should have 4 equal pieces, easier to do than thirds, like I said, to make them equal because we're just lining it up. So there's my 4 equal pieces. On one side, I will say 1/4, 1/4, 1/4, 1/4. On the back side, I'm going to say 1 divided by 4 because I like that one. I like to emphasize we are dividing 1 into that many equal pieces. And then I'm going to use halves as well to show some relationships. So 1/4 is 1/2 of 1/2, which we showed when we did half machine, half machine. Another important thing to realize is 1/4 is 1/2 times, this is times, that dot there, 1/2. Okay, when we do fractions and we say half of something, that's the same as half times something. Think about it. Half of 10 is 5, and half times 10 would also be 5. So this is going to be pretty much synonymous. The fraction of something is the same as the fraction times something. Since I already said my half of half and my half times half, that's the relationships I have for now. So I'll also say 1 out of 4
I often say
pieces.
4 quarters and $1 to help you remember that there are 4 fourths, each of which is 25 cents in 100 cents or $1.
Bam. All right. Next, we're not going to do fifths because fifths are a little extra tricky. They're like thirds, but you have an extra loop. So we're going to move right on to sixths. And I want you to think for a minute about how we might create sixths. It's going to, again, use machines we already have.
Like
Here.
half machine, third machine, fourth
Okay.
machine.
So think about it. Maybe some of you already know. If you think you know, why don't you pause this video and try it yourself. See if you make 6. That's a challenge. I usually have lots of students who think they know how to make 6 and then they make 8s. Okay, so that's a kind of a hint there. So, welcome back. If you pause the video and you challenge yourself to try, maybe you just have it in your head. All right, there's 2 ways to do this. Both of them involve a half machine because 6 is even, so that means it will have a 2 in it, and that helped us make the denominator because we're going to say half times something is 1/6. So half is our base, and then the other fraction will be third. Okay, so I'm going to do a loop-de-loop with this half here.
Sixth machine.
Hopefully that's good. How many pieces should I have now? If you said 6, you're correct. And those pieces better be equal. And 6 pieces will make a whole. Let's see if it works the other way.
Sixth machine, part 2.
Use the commutative property of multiplication here. So what if we did thirds first and then then halves? Would we get sixths?
Third machine, half machine.
There's my third. I did my loop-de-loo. Usually in class, students end up helping each other with this. If you're having a hard time with it, maybe there's someone at home that can help you. Oh, and I'm not quite perfect, so I have to discard that one. All right, scooch, scooch, scooch. Let's see if I can get this one. It's so hard to be perfect. Okay, this one might be good.
Third
All right, let's open it up
machine.
and see if that's thirds before we go on. It's pretty close. It's pretty much kissing that crease there. And that one as well. So here's my thirds. And now I'm going to fold it in half. So that means, if we can visualize before I actually do that, every one of these thirds will be cut in half. Will that give me 6 pieces? I'm sure some of you are way ahead of me on this, and that's great. And some people are still figuring it out, and that's great too. We're in all different
Half
places.
machine.
Just mastering fractions. And look, both of these are going to be sixths.
Sixth
Which color do you think
machine.
looks better? Maybe, just for pattern's sake, go back to blue here. All right, so on one side, we'll say
1 6 1 6 1 6 1 6 1 6 1 6.
6 times. On the back, we're gonna say 1 divided by 6 because I took this one whole and I divided it into 6 pieces. And one of those pieces would be 1/6. All right, I'm also gonna show the relationship. Got like a lump under here. Calm down, this is my kitchen table. Okay, so our relationship between half machine and third machine that we use to create 6. So we could say half of a third. So that's the second one I did when I made thirds, and then I took half machine again after that. We also could do 1/3 of 1/2. So we started with halves, and then we started with halves here, and then we divided each half into thirds. That would give us 6. Since this is synonymous with multiplication, we could also say half times a third and 1/3 times a half. That's our turnaround fact. It's also 1 out of 6. All right, last one we're gonna do is eighths. Looks like I'm on Pank. Pank time. Think to yourself, what would we use to make eighths? 8 is even. That means there's gonna be at least 1 half machine in there. Okay, maybe it will help you think about if we have 1/3 times 1/2 will be 1/6. 1/2 times 1/2 is 1/4. So what numbers could we get on the denominator side and the bottom to equal 1/8? What prime numbers could we use? So if you think you got it, why don't you pause this and try it. If you're feeling a little stumped, that's all right, I'll show you. So for eighth machine, we're gonna do a half machine. That will give me 2 pieces. All right, let's do half machine again. How many pieces will that be? If you said 4 or thought 4 to yourself, you were correct if you had 4 pieces. All right, so now how do we make fourths into eighths? How can we make fourths into eighths? Well, cut it in half again, fold it in half again. And so that means every fourth we had would now be 2 pieces. All right, 1, 2, 3, 4, 5, 6, 7, 8. 8 pieces make a whole, 8 equal pieces. So on one side we'll say 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8. All right, on the back, 1 divided by 8. 1 out of 8. All right, there's a few ways to write this now since we did 3 machines. Okay, we could say 1/2 times 1/2 times 1/2, or 1/2 of 1/2 of 1/2. Also, we could combine to these half machines and see that that's also a fourth machine and a half machine. So we could say 1/4 of 1/2, or 1/2 of 1/4, or half times a fourth, or a fourth times a half. So those are ways to make eighths. The challenge to try on your own is to make and label the 12th machine. So again, think about what the factors of 12 are and how that relates to the other machines. You already have a couple different ways you can make 12ths just based on these machines we just learned. So if you can make and label a 12th machine, bonus, nice work.